This is Module 10, Lesson 2, and we are going to be looking at how to graph systems of linear inequalities. You've done systems of linear equations. That's what we did in Module 9, and even a little bit in Module 10.1. Where you have a system that graphs out as two lines. The two lines can either cross, which means you have one solution where the lines cross. They can either basically sit one on top of the other, which means you have an infinite number of solutions, or you get two parallel lines which never cross, which means you have no solution. So those are systems of linear equations. Now we're going to take out the equal sign and replace it with an inequality sign, which means we've got to keep in mind we're going to have some shading to do. Now, if you will go back in time for just a second to what we did in Module 7, we did linear inequalities, but we only had one inequality that we were graphing at a time. So for instance, here's this linear inequality. We graphed it. We picked a point, figured out which way to shade. So if I put this point into the equation and it makes it true, I shade on this side. If the inequality sign is only a greater than or a less than sign, then remember we draw the line as a dashed line because points on the line do not make the equation true because it doesn't have that or equal part. If it does have greater than or equal to, less than or equal to, then we draw the line as a solid line. Okay, so we've done this, but now we're going to kind of put an extra layer on it, and you're going to start doing this, but you're going to have two lines on the same graph. Okay, so we're just going to get right into it. We have this system of linear, they even put equations, but that's inequalities. So this system of linear inequalities. And we're going to deal with one linear inequality at a time. I'm not going to worry too much about filling this stuff in because I don't always find it helpful. So here's what I'm going to do. I'm going to say, move my x over here. 3y is greater than negative x plus 3. Divide by 3. Divide by 3. Y is greater than negative 1/3 x plus 1. So that's this first inequality. Now, this is in slope-intercept form, so I can just take it. There's my y-intercept, here's my slope, and I can graph it using that. They also remind you that you do have the option of solving for your x and y-intercept, which gives you 2 points. And remember, these are all straight lines that we're graphing, so 2 points is enough to draw your line. I'm going to go ahead and use the slope-intercept form, and I'm going to come down here, and I'm going to get that graphed. All right, so I've got enough points, hopefully, to draw that line. I need to remember that the line is going to be dashed because it just says y is greater than. Okay, I probably could have done a little bit better on my dash line, but anyway, there's my dash line. And now I've got to figure out which way to shade. I like picking 0, 0 because it's an easy point to put into my equation. I would steer clear of 0, 0 if it's actually on your line, but it's definitely on this side of the line, so I'm going to use that. If I put in a 0 for x and a 0 for y, what I get is 0 is greater than 1. Which is not a true statement. So this side, which had 0, 0, is not making the inequality true, so I'm going to flip and I'm going to shade this top side. All right, so just a reminder, any point in this little purple area would make this particular linear inequality true. Okay, that's what we did in Module 7. Now we're going to add that extra layer because we're going to put a second equation on the same graph. Excuse me, a second inequality. All right, let me grab a different color pen. My second equation is right here. I'm going to go ahead and rearrange it. And that's going to give me y is less than or equal to x plus 6. Again, I have my slope, which is 1. I have my y-intercept, which is 6. So I can very easily graph it just from the equation. But I can also use x and y-intercept. So let's do that this time. Remember, if you want the x-intercept, you're going to put 0 in for y. So this is going to say 0 is less than or equal to x plus 6. And to get what x is, you're going to subtract 6. So x, and remember we can kind of think of that as an equal sign right now. My x-intercept is -6, 0. My y-intercept, remember this time you put 0 in for x if you want the y-intercept. So put a 0 there, and it's pretty obvious that my y-intercept is 6. So 0, 6. That gives me 2 points. 2 points is enough to draw a straight line. So -6, 0 and 0, 6. And this time I have less than or equal to, so when I draw this line, it will be a straight line. Sorry, they're all straight lines. I mean a solid line. So let me draw my straight solid line. Once again, this is a system of linear inequalities, so I also need to do some shading for this second line. I'm going to go back to the equation. Again, I like using 0, 0, although you do not have to use that point. But when I put in 0, 0, I get a statement that says 0 is less than or equal to 6. That is true. So my point that I picked is here. It made the equation true, so I'm going to shade on that side of the line. All right, I've now done my shading, and I'd like you to notice a few things. First of all, this is the area that was shaded with both colors. Okay, it made the linear inequality up here, y is greater than -1/3 x plus 1. This area made that linear inequality true. And then this whole area in maroon made the maroon linear inequality true. This area right through here is the solution, meaning any point in this area makes both parts of the system of linear inequalities true. So this is your area that's a solution. If you look and it's just shaded in purple, well, that is the area that makes this part of the inequality true, or system true, but it doesn't make both of them true. If you picked a point down here in the maroon area, it makes this inequality true, but not both of them. If you picked a point in this area where there's no shading, those points don't make either one of the linear inequalities true. Okay, but your solution, once again, is this area that makes both linear inequalities in that system true.